CPAP machine is an essential component of all level 2 and level 3 NICUs. In this webcast, we will learn the components and types of CPAP machines, cleaning, disinfection and troubleshoot with the use of CPAP machine will also be discussed. Delivering CPAP to a newborn involves giving oxygen ranging from 21 to 100%, giving CPAP pressure from 4 to 7 centimeters of water, delivering flow of air oxygen mixture at 2 to 7 liters per minute, and the required air oxygen mixture to be delivered at a temperature of 37 degrees and a relative humidity of 100% to the newborn nurse. For delivering oxygen from 21 to 100%, one would need a compressed air source such as an air compressor or a centralized gas source, compressed oxygen source such as an oxygen cylinder or a centralized gas source, and a blender to mix the pressurized air and oxygen to the desired fractional oxygen concentration. To generate CPAP, there is a need for flow of air and oxygen mixture in a closed tube and the presence of a CPAP generator. For delivering warm and humidifier air oxygen to the nurse, there is also need for servo controlled humidifier. This figure shows the components of an ideal bubble CPAP setup: air and oxygen, blender, flow meter, servo humidifier, inspiratory limb, nasal interface, expiratory limb and bubble chamber. This figure illustrates the generation of CPAP pressures in a closed tube connected to the lung. Air oxygen mixture is flowing in a T-piece connected to the lung. As the gas flows in the T-piece, air from the lung will be sucked into the tube due to Bernoulli principle. When the obstruction is built in the T-piece, as the gas is flowing in the tube, pressure builds in the T-piece and gas will now start flowing into the lungs till the pressure in the lungs equals the pressure that is built in the T-piece. The pressure built in the T-piece is proportional to the degree of obstruction or to the flow of gases in the closed T-piece. The obstruction to gas flow in the T-piece can also be achieved by immersing one end of the T-piece in a chamber of water. The pressure generated in the T-piece and in the lung is equal to the depth of immersion of the end of the T-piece. The greater the depth of immersion, greater is the pressure built in the T-piece. The depth of immersion of the T-piece inside the water from the water level is the pressure generated in the T-piece, provided the gas mixture is bubbling from the bubble chamber or the pressure generator. Compressed oxygen has 100% fractional oxygen and compressed air has 21% of fractional oxygen concentration. A blender mixes the compressed air and compressed oxygen to the desired fractional oxygen concentration ranging from 21 to 100% depending on the desired FiO2 one sets on the blender. The amount of gas coming from the blender is to be set by the flow meter that is fixed to the outlet of the blender. So, the blender is used to titrate the FiO2 of gas mixture and the flow meter is used to titrate the amount of gas mixture that is allowed to flow in the T-piece. A servo humidifier delivers the gas mixture to the newborn nurse at 37 degrees Celsius and at a relative humidity of 100%. To do this function, servo humidifiers are auto set for the exit of gas from the humidifier chamber at 37 degrees Celsius and reach a temperature of 39 degrees Celsius inside the inspiratory limb of CPAP circuit. The heating of gases to 37 degrees Celsius occurs in the water chamber of the humidifier and the gas heating from 37 to 39 degrees Celsius occurs in the inspiratory limb by a heating element present in the inspiratory limb. As the length of the heating element is restricted in the inspiratory limb up to a few centimeters away from the nurse of the baby, there is a drop in gas temperature from 39 to approximately 37 degrees Celsius in the inspiratory limb and just before reaching the nurse of the newborn. To ensure this estimated drop of gas temperature in the inspiratory limb, the last segment of the inspiratory limb should be inside the radiant warmer. The gas that exists from the water chamber is at a relative humidity of 100 degrees Celsius and as the gas gets heated in the inspiratory limb, that is from 37 to 39 degrees Celsius, there is a drop in relative humidity. Again in the last segment of the inspiratory limb, as gas temperature comes back to 37 degrees Celsius, equal to the temperature that is exited from the water chamber, gas reaching the newborn nares will always be 100% relative humidity. There are three types of CPAP machines depending on the type of pressure generator. In a bubble CPAP, pressure is generated by the bubble or water chamber. In a ventilator CPAP, pressure is generated by a valve or an obturator in the expiratory limb of the expiratory circuit, and CPAP is generated at a peculiar nasal interface by the degree of gas flow and fixed obstructive mechanism fitted in the nasal interface in an infant flow driver system. When using CPAP machine, always prefer a disposable circuit that is best suited for the type of machine. There is no need for routine scheduled replacement of the CPAP circuits. One circuit can be used for one baby. Always fill the water chamber of the humidifier with distilled water and use the autofill option available in the disposable circuits. Clean the CPAP machine with a soft cloth and ensure there is no water lagging in the CPAP circuit at all times. The major problem one faces when using a CPAP machine are alarms and malfunctioning of the blender, leaks in the circuit, condensation and water logging in the circuit, and inadvertent delivery of high pressures. The alarms from the blender occurs due to discrepancy in the gas pressures of oxygen and air reaching the blender. One need to replace the oxygen cylinder or the troubleshoot the air compressor to rectify the alarms from the blender. The blender needs recalibration once in every 3 months. Now, coming to the common sites of leaks in a CPAP circuit, they are at the inlet safety device, at the inlets of the temperature probe or the heater wires, and at the mouth of the newborn. The device, when working appropriately, avoids excess and inadvertent delivery of high pressures to the newborns. The water logging in the inspiratory limb is avoided by a working heater wire, ensuring environmental temperature is between 28 to 30 degrees Celsius, preventing the placement of temperature probe under the radiant warmer, and ensuring the placement of the last terminal segment of the inspiratory limb under the radiant warmer. The temperature probe should be covered with an insulating cloth or gauze if the probe falls under an incubator or in a radiant warmer. Now, the pressure generating water chamber should always be placed below the level of the newborn. If the water level increases, excess water will drain into the side chamber. However, if water evaporates, the water level could fall, resulting in reduced depth of immersion and reduced pressure generation in the CPAP circuit. In conclusion, a CPAP machine is a combination of pressure generator, delivery of fractional oxygen from 21 to 100% of oxygen, and delivery of warm and humidified gases to the newborn nares. In a bubble CPAP machine, the pressure generator is the bubble chamber. Fractional oxygen to desired level is achieved with compressed air, compressed oxygen, and a blender. Warming and humidified of gases is achieved with a servo humidifier. Thank you.